Hi guys, DK here from KaroroCAM. Today I'm going to be taking you through part 13 of this multi-part series on how to shape a kite surfboard using KaroroCAM. And today we are looking at materials, or in fact, and builds of materials and supply of those materials. We're getting close to the point where we're going to start machining the actual core of this board, and we'll need to start buying in some of these materials to get ready for the lamination. So first off is the core material. So this board is going to be vacuum infused, and that vacuum infusion is has very particular requirements for the core material. What we cannot use is like beaded EPS style packaging foam, because that is very porous, and actually during the infusion the core itself would want to soak up or be wet out by the resin. So we need a closed cell foam. So this what I've got on this BOM here is called XPS, which is extruded polystyrene foam, and in particular we're going to be using IsoBoard foam, which is a locally produced product here in South Africa. Now, internationally, most XPS foam is actually coloured. I think my friends in America, your XPS foam is sort of pink, or I've also seen blue, also known as styrofoam, I think, in that part of the world. But we have we have a local supply of a very bright white XPS, which is mainly used for insulation in homes and commercial buildings, but they do actually produce an 80mm thick block specifically for making surfboards. And one of the things that we have to keep in mind with what I know about XPS foam internationally is kind of known for delamination. But this locally made white foam, my experience has shown that it actually bonds very well, and I think that might be due to some of the foams available internationally have different fire retardants in them, and those fire retardants actually affect how the epoxy resin laminates onto the board. So I have actually gone out and I've sourced the block of foam we need for this particular application, and it's a 2-meter long block, 600mm wide and 80mm thick. The next thing we will need is our fin boxes, and we're using Futures for this particular project, and my friends over at Reef have helped us out with the project and are supplying us Future fin boxes from their stock. So these boxes, well, if you go back and look at some of the earlier videos, we've made all of the machining requirements to actually mount these up. When we come to laminate these, we will actually have to fill these slots in, and also where the grub screws are, because we do not need, we can't have these filling up with resin during the infusion. So that's going to be one of the little jobs that's required. So we've got both the front boxes and the rear boxes, and we also need a leash plug. And again, our friends at Reef have helped us out with that. So this will be machined, or dropped into a machined slot in the tail of the board. Then we move on to the actual lamination materials, and this board will be laminated in basalt fiber. Now, Aerontec is a company that I've been working with for quite a number of years. They're a composite supplier based here in Cape Town, and the link on this sheet, it actually just goes to their standard reinforcements page. The 200-gram basalt fiber that I'm using for this project isn't actually listed up on their site at the moment. I was able to get some from an early delivery, and I will actually supply. I will give Aerontec a link to these videos to sort of show this material in use. Now, what I like about basalt fiber is it's a step up in both stiffness and impact strength over standard glass fiber without being overly stiff like, say, carbon fiber. And it also is as easy to use in terms of wet out and handling as glass fiber. So yeah, that'll be a very interesting part of this project. Over the fiber, we will need a peel ply, and again, my friends at Aerontec will be able to supply that for us. And what an interesting part of this project is we will actually need spray adhesive. So this whole lamination stack, so all of this basalt fiber, the peel ply, these other materials will all actually be laid up into a vacuum bag as completely dry, and then will be wet out with via infusion. To aid in getting everything to sit correctly, we will actually use a spray adhesive to hold all of the materials in place. So that's what that's sitting there for. We will need some vacuum sealant tape, and again, Aerontec can supply that. The epoxy resin that we'll be using is one that I've had plenty of experience with, and it's this Sycamin Green Epoxy 33. This is a 33% bio-based epoxy resin, and we'll be using this with a very slow SD 77 series hardener, one that I've used in the past. I'll actually need to get Aerontec to advise which number it is, but it has a pot life in the region of about 1 hour, which will give us plenty of time to infuse this board. Another interesting item for this infusion is this membrane tubing or microporous vacuum strip. Now, we can get this from Aerontec, but they didn't have a link on their site. But I've put a link to Easy Composites have the same product. Now, this will end up you'll see where we use this in the actual lamination process, but it's an important part of setting up the vacuum infusion. We will need an infusion mesh, and I'm actually for this particular application, I'm actually quite a fan of just using standard sort of hardware store shade cloth. It's a little more flexible than some of the other or the more commercially available infusion meshes, which is going to be quite important for wrapping over the rails. So there's a link here to just my local hardware store. Stocks a 3 meter wide shade cloth that they sell per meter. So we'll be picking up some of that. We will also need some clear PVC tubing and some spiral binding for the resin inflows. Again, I just picked these up from my local hardware store. And finally, we will need an infusion fitting. Now, I have a one that I've designed specifically for this process, and there'll be a link to this Google Sheet in the description of this video. If you click on this link, you'll actually be able to download the STL file for this fitting. We'll print some off before we start the lamination, but you'll be able to download and print those for yourself if you'd like to replicate this particular process. So there we have it, guys. That's the bulk of the materials that we're going to be needing, or specialist materials that we're going to be needing for this particular lamination. As always, if you have any questions, feel free to put those in the comment section below, or you can email us KaroroCAM@gmail.com. Thank you very much.